Hi, I am Lakshmi, Department of Mathematics, SNS College of Technology. We discussed on some matrices and symmetric matrix with non-repeated eigenvalues. Here we derived using from this matrix one characteristic equation. From that characteristic equation, lambda equal to 369 we got at last. So I am continuing after this. Here we are calculating the eigenvectors. That general term for eigenvector is a minus lambda I into x equal to 0. Here after this substituting A matrix and minus lambda into I matrix. If you multiply all those things and we will get the final matrix as in the diagonal alone the minus lambda will come. So this way we got the A minus lambda I value, and x is x1, x2, x3 which is equal to 0 is 0, 0, 0. The equivalent matrix we wrote. So first in the three cases we are going to do. So first lambda value I am choosing. So lambda equal to 3. So 7 minus lambda is 4 and 6 minus lambda is 3. 5 minus lambda is 2. So here we got the 3 lambda values we substituted and we got the new matrix. In this new matrix we can replace by we can proceed the cross multiplication method. So taking first two rows, any two rows we can choose. I am choosing first two rows to calculate the work. So here the coefficients we wrote A, B, C and then again A. So first here the procedure is multiplying these two we get the answer for x3 value, and multiplying next to 2 we get the x1 value, and multiplying next to 2 we get the x2 value. So this way you can get a value. So x1 divided by first this cross minus this cross. So all those values I wrote here, and cross multiplied first cross minus second cross, I got the answer as 4. Next x2. So x2 these 4 values I wrote here. So first cross minus second cross multiplying these two I got the answer as 8. And then next these two values for x3 we wrote. So the first cross minus second cross the value becomes 8. So from this we got a 4, 8, 8, and we can choose the 4 as a common term. At last we got a 1, 2, 2 is the 3 values. From this x1 is 1 and x2 is 3, 2 and x3 is also 2. So we got the first eigenvector, that is x1 equal to 1, 2, 2. We got the first value. So same thing we are going to proceed the next value eigenvector. So next eigenvector I am taking is lambda equal to 6. So instead of that lambda in that same equation we can proceed. Here this lambda is 6. So substitute 7 minus 6, 6 minus 6 and 5 minus 6. In these three values alone we want to proceed. So 1, 0, minus 1 we got. So here we want to check each and every equation is same or different. So each and every equation is different. So we can go for the cross multiplication method. So I am choosing first two equations. In this equation first cross B and C. So B and C just choose it, and these two values alone I write it here and get a first cross minus second cross, conclusion is 4. Next x2. So next to x2 means, and then C and A, these two values you want to write here, and first cross minus next cross, the conclusion of this term is 2. Next x3, that is B and C, these two columns you want to write here. So first cross minus next cross. So multiplying these two values we got the answer as 4. So conclusion of this, so the common term is here, it is 2. So I am taking 2 outside. So x1 divided by 2 and x1 divided by 1 and x3 is divided by minus 2. So this way we got a value of second eigenvector x2 is 2, 1, minus 2. So next I move on to the third eigenvalue, lambda equal to 3. Lambda equal to 9. So lambda equal to 9 means next lambda 7 minus lambda, 6 minus lambda, and then 2 minus lambda, 5 minus lambda. So these three values we are replacing there. So each and every term the lambda value is changed, and then -2, -3, -4. The remaining values in the matrix are no change. Okay. So after this I am choosing first two equations. So in this x1 divided by first cross, these two values we can choose x1 divided by -2, -3, and 0, -2. So first cross minus second cross. Answer is 4. Next is x2. So x2 means these two values you want to choose, and 0, -2, -2, -2. So first cross minus second cross, the answer is -4. Next value is x3. So x3 in these two columns we want to choose. So first cross minus next cross. These two values you want to multiply and you will get as 2. Here also if we check the common term is 2. So 2 minus 2, 1. So we got this answer. So the third eigenvector is also we got, that is x3 equal to 2 minus 2, 1. So all those values we can write as a table. So in this table we can write, we will get a we can write all the eigenvalues and corresponding eigenvectors. Thank you.